Hello class, this is Brian here, and today I'm here to talk to you about image compression. So what we're going to focus on is the compression of true color images. So before anyone or anything gets started, let's pick our picture. So I'm going to pick this picture. It's the Chicago skyline. It's much better than the Virginia skyline because, look at it. It's just so many more buildings, nice, pretty full, I guess. And Virginia sucks, so I'm gonna go troll face right now and pick the Chicago skyline. Alright, now starting from the given image, the goal of true compression is to minimize the number of bits needed to represent it, while storing information of an acceptable quality. The purpose of this example is to show you how to decompose, compress, and decompress a true color image using compression by global thresholding and Huffman encoding. This lossless compression algorithm is simple and is quite a remarkable method for selecting the threshold. Now, what is thresholding, you may ask? Well, thresholding is the simplest method of image segmentation. Lossless data compression is a class of data compression algorithms that allow the exact original data to be reconstructed from the compressed data, meaning nothing gets destroyed or deleted when you compress it. So let's open up our let me close all this. I had to make sure it worked. Let's open up our MATLAB. As you can see, I have stuff here, so we're going to clear it. Yeah. Alright, so now all that's gone. Now you have to download your image and then you have to save it in your MATLAB directory. I've done that here, as you can see, skyline.jpg. It's a JPEG picture. So, we need to begin, right? I would type it for you, but it'll just take forever. So you're just gonna see a whole bunch of copy and pasting from code I've written already. Well, this is where you initialize and actually bring the picture into the code. This is the mread. This is what's basically putting the picture in here, and you're putting it as, in this example, Chicago. So we're gonna do that, and now the picture is in our workspace. Now, because we're going to do more than one compression, we need to start setting up, our subplots and making everything look all fancy. This is what these line of codes do. They're very simple. And now you can see we have the picture and we have the title, better than Virginia. And this is the original picture. Alright, now we're getting ready to start doing some fancy stuff. Well, the first thing we have to do is to put in our method for compression. I already told you that we're going to use global thresholding and Huffman encoding, and that's pretty much what this line of code stands for. Meth is method because we're not going to write out the whole thing due to laziness. So now that we put that in there, the next line of code is also important. This is our compression code. Well, not really our compression code, but this is what sets it up. It's where you put in the option and C. C is for compression. It's very, very simple. Next is when we pick our compression ratio. We set the name of the compression image. And we actually put what to compress and the option that we're using. That's what this line of code does. It compresses the image Chicago, which we've imported. This is what it's going to name it. It's going to use the method, image compression, right there. And this is what it's going to compress by. Alright, so we're going to put that in, and you're going to get these numbers. You have CR and BPP. Well, CR stands for compression ratio, and BPP stands for bit per pixel. Now the CR and BP represent equivalent information. CR indicates the compressed image is stored using the compressed ratio's percent of the initial storage size, while the BPP is the number of bits used to store 1 pixel of the image. For a true color image, the initial BPP is 24 because 8 bits are used to encode each of the 3 colors. RGB. So, now, since we've compressed the image, we need to go and start decompressing it. Option U for uncompress. Fairly simple. Now we need to set the uncompressed image to a variable. This line will do that. Since it's compressed, we're going to name it from Chicago to Chi-Town. So now Chi-Town will be initialized as this image. So since we want to have this image next to our picture, we're going to do a subplot next to it along with some fancy stuff. That's what these lines of code are going to do right here. Make everything look all nice and fancy. Now, we're doing a label at the bottom of this one to show the compression ratio and the BPP. That way you can see it as we go throughout the compressions. And we're going to look at the image. Now, I'm going to expand this for you. As you can see that the original image is extremely sharp. It looks nice. Now this one, while you can start to see that between the skyline and the sunset, there's some blur. I mean, it still looks better than the Virginia skyline right now, but you can see there's a noticeable difference between the original. So we're just going to compress this image. We're going to compress it again, and then we're going to see what they look like. Now that's fairly simple. I mean, I've already showed you how to compress it, so we're just going to take our compressed images and compress them. So here you go. It's going to calculate the CR and the BPP, but none of that matters because it's the same. We never changed it. Oh, it seems I've copied a little too much right here, but that's relatively unimportant as long as you guys get the general gist of how you're supposed to compress images. Now you can see all the images. Why would the two images on the bottom be much bigger than the originals? Well, when you compress an image, since we're using lossless data compression, all the data is there. So it has to expand it out to make sure it represents all the data. As you can see, the data gets more and more blurry, less sharp as it's compressed and compressed again, because now it looks like there's fog in the picture and all the buildings are fat or whatever. You know, it really doesn't matter because all the data is there, and this is used in medical imaging a lot because it can capture the data and leave it there. If you ever need to uncompress it, you can always do that. So this is a very important compression technique that's used a lot. Okay? Well, sorry for going troll face on Virginia, but that's pretty much how I feel about it. I mean, they don't even really have a football team. Redskins, really? That's not a Virginia team. Well, I hope you guys have enjoyed this lesson and learned something. Have a nice day. Goodbye. I am Blackboard. I am Blackboard.